Hey friends, welcome to this Salesforce Apex tutorial. With its Java-like syntax, easy to use and strongly typed attributes, Apex is becoming popular every day. So let's learn fundamentals of Salesforce Apex and Apex testing in this tutorial. And if you have missed the previous Salesforce tutorials or any of the business analysis tutorial, use the links in the description box. Let's begin with the what is Salesforce Apex now. So friends, first thing first, what is Apex? Salesforce Apex is the world's first on-demand strongly typed programming language developed by Salesforce.com. Apex is an object-oriented language similar to C# and Java that allows to implement complex business requirements on the Force.com platform. Also, Apex is designed to process large amounts of data to add business logic to applications and to write controller in the MVC architecture. Apex language is a multi-purpose programming language and exists in multi-tenant environment. Apex classes and triggers can be written in developer and sandbox organization. Test methods are written to implement Apex code. The code coverage must be greater than 75%. Apex can perform DML operations like insert, update, upsert, delete on S-object records using Apex. Every resource that executed using Apex programming language are effectively controlled for high quality of service to all Salesforce developers. Now let's look at some features of Salesforce Apex. Salesforce offers data manipulation language (DML) with built-in exception handling. Salesforce Object Query Language (SOQL) and Salesforce Object Search Language (SOSL) are used to query and retrieve data. Apex in Salesforce has built-in record locking mechanism. This prevents record update conflicts. Salesforce Apex programming language runs on multi-tenant environment. Apex code is stored in metadata format. It has syntax and variables similar to Java. It provides unit testing and test execution with code coverage. When we want to add web and email services to your application, it is used to perform complex business processes. When can add complex validation rules to your application. And last but not the least, Salesforce Apex can be used to add a custom logic on operations like saving a record. When discussing about working structure of Apex, we should know about two sequence of actions that happens when developer save the code and end user actions. Apex programming language runs entirely on Force.com platform. When a developer writes and saves a code in the platform, the code gets compiled and stores in the form of metadata in Salesforce servers. Now the end user sends request from user interface and retrieve the results from Salesforce servers. Following are the flow of actions for an Apex code. Developer action. All the Apex code written by a developer is compiled into a set of instructions that can be understood by Apex runtime interpreter when the developer saves the code to the platform, and these instructions then save as metadata to the platform. End user action. When the user event executes an Apex code, the platform server gets the compiled instructions from metadata and runs them through the Apex interpreter before returning the result. Apex uses data types, variables, and related language constructs such as enums, constants, expressions, operators, and assignment statements. Data types. In Apex, all variables and expressions have a data type, such as S-object, primitive, or enum. Primitive data types. Apex uses the same primitive data types as SOAP, except for higher precision decimal type. In certain cases, all primitive data types are passed by value. Collections. Collections in Apex can be lists, sets, or maps. Enums. An enum is an abstract data type with values that each take on exactly one of a finite set of identifiers that you specify. Enums are typically used to define a set of possible values that don't otherwise have a numerical order. Typical examples include the suit of a card, or a particular season of the year. Variables. Local variables are declared with Java-style syntax. As with Java, multiple variables can be declared and initialized in a single statement. Constants. Apex constants are variables whose values don't change after being initialized once. Constants can be defined using the final keyword. Expressions and operators. An expression is a construct made up of variables, operators, and method invocations that evaluates to a single value. Assignment statements. An assignment statement is any statement that places a value into a variable. Rules of conversion. In general, Apex requires you to explicitly convert one data type to another. For example, a variable of the integer data type cannot be implicitly converted to a string. Apex access specifier. Public. This access specifier gives access to a class, method, variable to be used by an Apex within a namespace. Private. This access specifier gives access to a class, method, variable to be used locally or within the section of code it is defined. Protected. This access specifier gives access to a method, variable to be used by any inner classes within defining Apex class. Global. This access specifier gives access to a class, method, variable to be used by an Apex within a namespace as well as outside of the namespace. Apex classes. Similar to Java, you can create classes in Apex. A class is a template or blueprint from which objects are created. An object is an instance of a class. For example, the purchase order class describes an entire purchase order, and everything that you can do with a purchase order. An instance of the purchase order class is a specific purchase order that you send or receive. A class can contain variables and methods. Variables are used to specify the state of an object, such as the object's name or type. Since these variables are associated with a class and are members of it, they are commonly referred to as member variables. Methods are used to control behavior, such as get other quotes or copy line items. A class can contain other classes, exception types, and initialization code. We can see an example on the screen. An interface is like a class in which none of the methods have been implemented. The method signatures are there, but the body of each method is empty. To use an interface, another class must implement it by providing a body for all of the methods contained in the interface. Interfaces can provide a layer of abstraction to your code. They separate the specific implementation of a method from the declaration for that method. This way you can have different implementations of a method based on your specific application. Defining an interface is similar to defining a new class, as shown on the screen. These are the major differences between Apex classes and Java classes. To begin with, inner classes and interfaces can only be declared one level deep inside an outer class. Static methods and variables can only be declared in a top-level class definition, not in an inner class. An inner class behaves like a static Java inner class, but doesn't require the static keyword. An inner class can have instance member variables like an outer class, but there is no implicit pointer to an instance of the outer class, using the this keyword. The public access modifier means the method or variable can be used by any Apex in this application or namespace. Methods and classes are final by default. The override keyword must be used explicitly on methods that override base class methods. Interface methods have no modifiers, they are always global. Their names must end with the word exception. Classes and interfaces can be defined in triggers and anonymous blocks, but only as local. Apex transactions ensure the integrity of data. Apex code runs as part of atomic transactions. Governor execution limits ensure the efficient use of resources on the Lightning Platform multi-tenant platform. Most of the governor limits are per transaction, and some aren't, such as 24-hour limits. Apex transactions. An Apex transaction represents a set of operations that are executed as a single unit. All DML operations in a transaction either complete successfully, or if an error occurs in one operation, the entire transaction is rolled back and no data is committed to the database. Execution governors and limits. Because Apex runs in a multi-tenant environment, the Apex runtime engine strictly enforces limits so that runaway Apex code or processes don't monopolize shared resources. If some Apex code exceeds a limit, the associated governor issues a runtime exception that can't be handled. Set up governor limit email warnings. You can specify users in your organization to receive an email notification when they invoke Apex code that surpasses 50% of allocated governor limits. Running Apex within governor execution limits. Because resources are shared in a multi-tenant platform, the Apex runtime engine enforces some limits to ensure that no one transaction monopolizes shared resources. The next obvious question comes to our mind: where to write the Apex code? There are several development environments for developing Apex code. Developer Console. The Developer Console is an integrated development environment with a collection of tools you can use to create, debug, and test applications in your Salesforce organization. Salesforce extensions for Visual Studio Code. The Salesforce extension pack for Visual Studio Code includes tools for developing on the Salesforce platform in the lightweight, extensible VS Code editor. These tools provide features for working with development orgs, Scratch orgs, sandboxes, and the orgs, Apex, Aura components, and Visualforce. Code editor in the Salesforce user interface. The Salesforce user interface. All classes and triggers are compiled when they are saved, and any syntax errors are flagged. You cannot save your code until it compiles without errors. The Salesforce user interface also numbers the lines in the code, and uses color coding to distinguish different elements, such as comments, keywords, literal strings, and so on. As we all know, testing is key to the success of your application, particularly if your application is to be deployed to customer. Before you can deploy your code or package it for the Salesforce Apex change, the following conditions are really crucial. Also, these conditions are often asked in the Salesforce testing interviews. Unit tests must cover at least 75% of your Apex code, and all of those tests must complete successfully. When deploying Apex to a production organization, each unit test in your organization namespace is executed by default. Calls to system debug are not counted as part of Apex code coverage. Test methods and test classes are not counted as part of Apex code coverage. While only 75% of your Apex code must be covered by tests, don't focus on the percentage of code that is covered. Instead, make sure that every use case of your application is covered, including positive and negative cases, as well as bulk and single records. This approach ensures that 75% or more of your code is covered by unit tests. Every trigger must have some test coverage. All classes and triggers must compile successfully. Now, what to test in Apex? Single action. Test to verify that a single record produces the correct, expected result. Bulk actions. Any Apex code, whether a trigger, a class or an extension, may be invoked for 1 to 200 records. You must test not only the single record case, but the bulk cases as well. Positive behavior. Test to verify that the expected behavior occurs through every expected permutation, that is, that the user filled out everything correctly and did not go past the limits. Negative behavior. There are likely limits to your applications, such as not being able to add a future date, not being able to specify a negative amount, and so on. You must test for the negative case and verify that the error messages are correctly produced as well as for the positive, within the limits cases. Restricted user. Test whether a user with restricted access to the S objects used in your code sees the expected behavior, that is, whether they can run the code or receive error messages. Unit tests are class methods that verify whether a particular piece of code is working properly. Unit test methods take no arguments, commit no data to the database, and send no emails. Unit test methods must be defined in test classes as described in the example. Let us talk about the test data in Apex. Apex test data is transient and isn't committed to the database. This means that after a test method finishes execution, the data inserted by the test doesn't persist in the database. As a result, there is no need to delete any test data at the conclusion of a test. Isolation of test data from organization data in unit tests. By default, Apex test methods can't access pre-existing org data such as standard objects, custom objects, and custom settings data. They can only access data that they create. Loading test data. Using the test load data method, you can populate data in your test methods without having to write many lines of code. Follow these steps. Add the data in a .csv file. Create a static resource for this file. Call test, load data within your test method and passing it the object type token and the static resource name. To verify the functionality of your Apex code, execute unit tests. You can run Apex test methods in the developer console, in setup, in the Salesforce extensions for Visual Studio Code, or using the API. You can run the following groupings of unit tests. Some or all methods in a specific class. Some or all methods in a set of classes. A predefined suite of classes, known as a test suite. All unit tests in your org. Now, to run a test, use any of the following. The Salesforce user interface. Salesforce extensions for Visual Studio Code. The Lightning Platform Developer Console. Use the API. You can't develop Apex in your Salesforce production org. Your development work is done in either a sandbox or a developer edition org. You can deploy Apex using change sets. Salesforce extensions for Visual Studio Code. The Ant migration tool. SOAP API. Third-party tools that use metadata API, a tooling API. VS Code with Salesforce DX plugins. A trigger is Apex code that executes before or after the following types of operations: insert, update, delete, merge, upset, and undelete. There are two types of triggers. Before triggers are used to update or validate record values before they're saved to the database. After triggers are used to access field values that are set by the system, such as a record's id or last modified date field, and to effect changes in other records, such as logging into an audit table or firing asynchronous events with a queue. The records that fire the after trigger are read-only. For example, you can have a trigger run before an object's records are inserted into the database, after records have been deleted, or even after a record is restored from the recycle bin. All triggers are bulk triggers by default, and can process multiple records at a time. You should always plan on processing more than one record at a time. Bulk triggers can handle both single record updates and bulk operations like data import, Lightning Platform bulk API calls, mass actions, such as record owner changes and deletes, recursive Apex methods and triggers that invoke bulk DML statements. To define a trigger, use the syntax as shown on the screen. Please note, where trigger_events can be a comma-separated list of one or more of the following events: before insert, before update, before delete, after insert, after update, after delete, after undelete. How to expose Apex methods as SOAP web services? You can expose your Apex methods as SOAP web services so that external applications can access your code and your application. Apex class methods can be exposed as custom SOAP web service calls. This allows an external application to invoke an Apex web service to perform an action in Salesforce. Use the web service keyword to define these methods. Look at the example shown on the screen to understand this. Now, how to expose Apex classes as REST web services? You can expose your Apex classes and methods so that external applications can access your code and your application through the REST architecture. You can expose your Apex class and methods so that external applications can access your code and your application through the REST architecture. This is done by defining your Apex class with the @REST resource annotation to expose it as a REST resource. Similarly, add annotations to your methods to expose them through REST. These are the classes containing methods and properties you can use with Apex REST. REST context class contains the REST request and REST response objects. Request use the system REST request class to access and pass request data in a RESTful Apex method. Response represents an object used to pass data from an Apex RESTful web service method to an HTTP response. Next, what is email service? You can use email services to process the contents, headers, and attachments of inbound email. For example, you can create an email service that automatically creates contact records based on contact information in messages. You can associate each email service with one or more Salesforce-generated email addresses to which users can send messages for processing. To give multiple users access to a single email service, you can associate multiple Salesforce-generated email addresses with the email service and allocate those addresses to users. Associate a single Salesforce-generated email address with the email service, and write an Apex class that executes according to the user accessing the email service. For example, you can write an Apex class that identifies the user based on the user's email address and creates records on behalf of that user. To use email services, from Setup, enter Email Services in the Quick Find box, then select Email Services. Click New Email Service to define a new email service. Select an existing email service to view its configuration, activate or deactivate it, and view or specify addresses for that email service. Click Edit to make changes to an existing email service. Click Delete to delete an email service. Batch, as the name suggests, is used when a large data bulk volume is involved. Batch Apex Salesforce allows you to define a single job that can be broken up into manageable chunks, where query chunk can be processed separately. Batch class in Salesforce is used to process a large number of records that would exceed the Apex governor limits if processed normally. Batch class executes the code asynchronously. Following are the advantages of batch class. To use the batch Apex, we should write an Apex class that implement database. Batchable interface. Database. Batchable interface consists of three methods that must be implemented. They are start method, execute method, finish method. Let's now take a look on the three batch methods: start, execute and finish. Start method. Start method is automatically called at the beginning of the batch Apex job. This method will collect the records or objects on which the operation should be performed. The records are broken down into subtasks and given to execute method. Execute method. The records which are fetched from the start method are divided into batches of 200 records each. Now every batch of 200 records are separately passed to the execute method separately, and the operation what we want to perform on the records written in the execute method. Database. Query locator. Use database. Query locator is return type to the start method when you are fetching the records using a simple select query. Finish method. When the start method has fetched 1000 records on which we want to perform the operation, they are divided into 5 batch or groups, each batch or group of size 200 records. On every batch, the execute method is called 5 times. After executing every batch, the governing limits are reset for the execute method. Once all the batches are executed, then finish method will be called to send email notification for post-execution work. Let's recap what we have learned so far. There are 3 ways of creating Apex classes in Salesforce: Developer Console, Force.com ID, and Apex Class Detail page. Apex is a strongly typed, object-oriented programming language that compiles and run on Force.com platform. Apex programming language is a case-insensitive language. Data types supported are primitive, collections, S-object, enums, classes, objects and interfaces. Public, private, protected and global are specified support by Apex. Keywords in Apex are with sharing, without sharing, static, final, return, null, virtual, abstract. Apex governor limits are the limits enforced by Apex runtime engine to ensure that any runway Apex code and processes. Apex triggers enable you to execute custom Apex before and after a DML operation is performed. Batch class in Salesforce is used to process a large number of records that would exceed the Apex governor limits if processed normally. So friends, this is just a beginning of learning Salesforce Apex. You need to learn deeper and practice a lot if you want to gain expertise in Apex programming. Did you like this tutorial? Please write in the comments and what more you would like to learn. And friends, please don't forget to like, share and subscribe. Thanks for watching and loving the videos. See you in the next one.